टाइप फिल्टर सर्किट ट्रेनर किटमा स्वागत छ। TN5 टाइप यो चाहिँ एसपारा इलेक्ट्रोनिक्स भक्तपुर मड इन नेपाल. In this tender kit we can hold for experiment low pass TLC filter, low pass pi LC filter, high pass TLC filter, pi LC filter and TLC filter also. And first in here you can see the value of inductor and capacitor, and here is inbuilt function generator. You can adjust the amplitude by here. Okay, you can see in oscilloscope, and you can change the frequency by here. You can see in oscilloscope. Okay, you can see, and also you can change the frequency. This is the range selector, 100 kilohertz by this toggle switch. First we have to set peak to peak voltage, channel 1 peak to peak voltage in near about 2-3 volt. Okay, here is 6 point written in here. Here is 2.4 volt. I can increase the amplitude in here. Okay, you can see the range in 500 not, it's in 1 kilohertz, 1 volt range, and frequency is 6 kilohertz. I have to reduce it on near about 1 kilohertz for this experiment. Okay, I have to put in near about 1 kilohertz. Here you can see in here 927 hertz. And first we are going to low pass TLC filter, connect phase to phase and neutral to neutral, also a positive terminal and negative terminal, and you have to connect. Be carefully, positive terminal is in positive and negative terminal is negative terminal of oscilloscope. Channel 2, here you can see channel 1 peak to peak voltage is 1.24 volt, channel 2 is also 1.24 volt, frequency is same. This is low pass filter. You can calculate the cutoff frequency around 7.14 kilohertz. So here is the range of this frequency is below this range, so this is passing from here. When I increase the frequency, you can see here is similar, here is similar. Also I am changing the duty cycle of oscilloscope. You can see. Okay, channel 1 channel 2 input and output are similar, but here is channel 1 reduced and channel 2 increased. This is not affect to you because it's going to near cutoff frequency. So I am providing the output. Here is channel is 1 is 2.76, channel is 4.28. This is not affecting to you. I am not changing the amplitude, but here is automatic. It can create some resonance. That's why its amplitude is changing. And I am going to near about 7.14 volt. Here is channel 1 is 5.68 and channel 2 is 5.60. That's why our cutoff frequency is near 7 kilohertz. Here is also frequency is 7 kilohertz. Now I am changing, rising the frequency from here to here. Here is channel, here is frequency in 7.65, channel 1 frequency peak to peak voltage is 5.16, but channel 2 peak to peak voltage is 3.76. When also you increase the frequency, here is channel 2 voltage is reducing. Here is 3.60 channel 1 and channel 2 1.44. This is the amplitude of channel 2 also reducing. Now I am making the frequency about 12.15 kilohertz. Here is channel 1 peak to peak frequency is 1.96 and channel 2 peak to peak frequency is 680 near of millivolt peak to peak voltage. That's why after cutoff frequency the amplitude of output is going to reduce continuously when we increase the frequency. This is low pass TLC filter. Now I am going to other 5 low pass LC filter. So I am changing this terminal to this terminal now, just, and for bring this terminal and this terminal. Do not interchange the positive terminal and negative terminal, because that can create the short circuit in your oscilloscope. So here is I am reducing the frequency in about 2 kilohertz. Here is input and output near about similar peak to peak voltage. I can increase by, here is this knob, and when I increase the frequency 5 kilohertz, channel to peak voltage is greater than channel 1. This is pass voltage, this is passing. When I increase it about 7, okay, channel 1 3.08, channel 2 4.24, also is pass. When I pass it 7.65, channel 1 2.96, and channel 2 2.76, also this pass. And when I increase about 10 kilohertz, channel 2 920 millivolt, and channel 1 2.336 volt. This is output voltage is very much lower than input voltage, so this is block band frequency. So this is low pass filter. And in case of T type high pass filter, I am connect to this terminal and this terminal. By this way I reduce the frequency near about 0. Okay, this is 2 kilohertz. Okay, you can see the input is 2 volt is correct, but output is 0. This is plain line. This is block band frequency. It's I forget it, you can calculate near about 4 kilohertz is pass band frequency. So when I increase the frequency near about 4 kilohertz, so channel 1 and channel 2 are similar, so this the frequency is passed from here. When you increase the frequency, the channel 2 output frequency is peak to peak voltage is getting higher and higher, so this is pass band frequency. Okay, by this way you can continue your experiment. Here is frequency is about 12 kilohertz, this passed. I also increased the frequency around 87 kilohertz, this also passed. 50 kilohertz, 31 kilohertz, this also passed. But in case of below 2 kilohertz, you can this block the frequency 4 kilohertz. Okay, this is high pass T type LC filter. And another I am going to fight of LC filter. It has slightly lower than 50% impedance, so it can drag the higher current than this device. So here is frequency is, I am putting here frequency is 1 kilohertz. This is 1.96, but channel 1 is, you can see the waveform, but in channel 2 you couldn't see the waveform. This is plain, there is no pass. When you increase the frequency, here is both amplitude are rising, but it goes to equivalent amplitude when it goes to cutoff frequency about 4 kilohertz. Okay, you can see channel 1 and channel 2 similar waveform. Okay, 4.17, this is on cutoff frequency. When you increase the frequency, pass band is begin, and thus input and output are similar way, you can see. Okay, I reduce the amplitude both. Okay, you can see when I increase the frequency, also you can see pass band frequency. Okay, there are both are passed, so this is high pass frequency. This is only instruction for how to handle this device. Thank you.